How many students are joined right now? 31 now. Okay. Listen here. All of you listen here. Guys, sequence and series. Okay. First definition for sequence. A set of numbers A1, A2, A3, etc. An such that to each positive integer n, there corresponds a an if the set is called a sequence and it is denoted by within that bracket an. Okay, the an we can write it as in the bracket, that is sequence. Okay, a set of numbers a1, a2, etc. An, etc. such that to each positive integer n there corresponds a an if the set is called a sequence and it is denoted by an. Okay guys, this is the definition for sequence. Next one note, in a set the order of the elements may be in any order. Okay, in a set the order of the elements may be in any order, but in a sequence, okay, in a sequence the elements are arranged in a definite order only. Okay, in a sequence the elements are arranged in a definite order. Examples, if an equal to 1 by n, okay, this is on sequence an equal to 1 by n, the sequences, how can we write? See, 1 1 by 2 comma 1 by 3 etc. 1 by n. Okay, for this sequence is nth term, we can write it as 1 by n, that is an. Okay guys, example understood?
Yes, ma'am.
Okay, if an equal to 1 by n, then the sequence can be written as 1 comma 1 by 2 comma 1 by 3 etc. 1 by n. And if an equal to k, what will be the sequence? Guys, only k.
Constant
to
k
infinite.
comma k.
K comma k etc. Okay, next consider the sequence n by n plus 1. Okay, we are considering one sequence n by n plus 1. Here limit approaches to infinity. Limit n tends to infinity. What will be the value? Limit n tends to infinity, n by n plus 1. Limit n tends to infinity, n by n plus 1. In the numerator, n, in the denominator, take outside one n common, n into 1 plus 1 by n. 1 by infinity value 0. We are getting now 1. Okay.
Okay,
Limit
ma'am.
n to infinity, n by n plus 1 equal to 1. That is, the terms of the sequence can be arbitrarily closed to the limit L. Arbitrary, not equal to 1. Arbitrarily closed to the limit L by taking n sufficiently large. Okay, see the diagram. First that n plot that n, that line, the dotted line, that is closed to the limit. Okay, the terms of the sequence can be arbitrarily close to the limit L by taking n sufficiently large. Okay guys, understood?
Yes, ma'am.
Okay, next, if limit n tends to infinity an exists, we say that the sequence converges, otherwise it diverges. Okay, if limit n tends to infinity an is exist, we say that the sequence converges, otherwise it diverges. Okay, this is important thing. Keep it in your mind. If the sequence an is exists, limit n tends to infinity, an exists, we can say that the sequences converges, otherwise diverges. Next, oscillatory sequence. Oscillatory sequence means within that 1 to that -1 oscillatory, which does not converge and does not diverge. For example, -1 to the whole power n. Okay, that is the oscillatory sequence. Now, if we have, once you go through fully, if we have any doubt in this page, first you ask me and then we'll go for the next definition. Once you go through fully, line by line, go through slowly, no problem. Because this is a small chapter, simple chapter only. I think 7, 8 tests are there. We can easily finish the syllabus, no issue. But you have to understand each and everything line by line. You go.
Ma'am, how much units will come in CT3?
No, I think all 5 units, but not sure. I think all 5 units because they are first they said that only 4th and 5th chapter, but few days or I think 2 weeks before, I don't remember correctly, but they are going to conduct in Kotandra. Means
Yes, ma'am.
seniors they are attended the final exam in Kotandra only, no? For that practice, they are conducting the model exam in Kotandra for first years. It may be, I think, all 5 chapters. You did
Okay,
not
ma'am.
get any information from your class in charge side, or?
No.
No? Oh. Okay, I will tell you. I will ask and then tell you. Okay.
Okay, ma'am.
I think in Kotandra only your model exam going to conduct. That one is I think sure. But a portion, if they are conducting a Kotandra, definitely they will, because before that final exam in that model, that is in CT3, always all the 5 chapters only will come. Okay.
Okay, ma'am.
Okay. In the seniors exam pattern is 31 mark question MCQ they are attended, and 15 2 mark questions. Okay, 15 2 mark question. You have to write the answer and then you have to upload in that Kotandra, and 5 or 6. Yes, 5 3 mark questions also. Okay, not only MCQ. You have to write the answers in your own paper, and then again you have to upload in Kotandra. Okay, guys.
Yes, ma'am. Okay.
Okay, ma. Okay. If you have any doubt in this page, you ask me in sequence and series. No doubt means you tell me. I will go to the next page. Guys, are you listening?
Yes, ma'am.
Yes, ma'am.
Okay. Shall we go to the next page, or?
Okay, ma'am. Next page.
Okay. Okay, guys, this is visible for you. Monotonically increasing sequence. Guys,
Yes, ma'am.
okay, ma. Examples of monotonically increasing sequence. Okay, that arrows means increasing. Okay, example of monotonically increasing sequence. Okay, if you are taking an equal to n. Okay, an equal to n. Then what is an plus 1? An plus 1 equal to, we can write n plus 1. Am I right? An
Yes, ma'am.
equal to n. An plus 1 equal to, we can write n plus 1. Okay. Then find an plus 1 minus an. An plus 1 is n plus 1. Minus an is n. Okay. Here n opposite sign we are getting equal to 1. Okay, equal to 1, which means this is greater than 0. Okay, positive number. Okay, if we get an plus 1 minus an is greater than 0 means we can say that the sequence is monotonically increasing sequence. Okay, an plus 1 minus an is greater than 0 means monotonically increasing sequence. In case if we get less than 0 means
Monotonically
Monotonically
decreasing
decreasing statements.
that's a simple thing. Okay. Next example. Yeah, n square also increasing. You just check for n square. N square, an equal to n square. An plus 1. N plus 1.
square.
N plus 1 whole square.
Okay. An plus 1 minus an. That is n plus 1 whole square minus n square. What will be the answer? You just check.
2n
2n
plus 1.
plus 1.
N plus 1.
What is the answer?
2n plus 1.
2n plus 1, na?
Yes, ma'am.
Yes, ma'am. 2n plus 1, so it would be greater than 0. Hence, it is monotonically
Yeah.
increasing sequence.
Okay, okay,
Yes,
exactly.
ma'am.
Okay. Next one, next example. N plus
And that
1
is
by
monotonically increasing.
second one also.
Yes, ma'am.
N plus 1 by 2n plus 3. You just check an plus 1 minus an condition. Okay. An plus 1 means here n plus 1 is there. N plus 1 plus 1 by 2n plus 1 plus 3 minus an. This is an. And then taking cross multiplication we will get, finally it will come greater than 0. Okay, you check. Once you check, yeah, everybody check. Write this question, you check. All of you check. Guys, are you checking?
Yes, ma'am, checked. It's
Okay.
monotonically increasing.
Checked. Boys,
Yes, ma'am.
got the answer?
Ma'am, monotonically increasing.
Okay. Okay. Next example, 1 by 2 power n. This is an. An equal to 1 by 2 power n. Okay. An plus 1. 1 by 2 power n plus 1. Okay. Sometimes instead of 1 by 2 power n, they can give 1 by 2, comma 1 by 2 square, comma 1 by 2 cube. Okay. We have to take from this sequence an as 1 by 2 power n. Okay. We know that a1, a2, a1, comma a2, comma etc. equal to an. That is here 2 power n is 1 by 2, comma 1 by 2 square, comma 1 by 2, 3, etc. Okay. An plus 1 is 1 by 2 power n plus 1. Okay. 2 power n plus 1 can be written as 2 power n into 2. Okay. 2 power n into 2. This is an minus, sorry, an plus 1. This is an plus 1 minus an. In the two terms, 2 power n common, taking outside 2 power n common, it will be 1 by 2 minus 1. Half minus 1 minus half. Minus half into 1 by 2 power n, which is less than 0. Less than 0 means
Monotonically decreasing sequence.
decreasing series. Okay. Sequence. Greater than 0 means an plus 1 minus an greater than 0 means monotonically increasing. An plus 1 minus an less than 0 means monotonically decreasing. Okay. Is it clear?
Yes, ma'am.
Yes. Next. Okay. Now, this is the definition for a series, infinite series. Okay, listen here. Infinite series. If an is a sequence, okay, if an is a sequence, then summation n is equal to 1 to infinity an equal to a1 plus a2 plus etc. infinity is called the infinite series. That series is nothing but the total values, sum of the values. Okay. If an is a sequence, then summation n is equal to 1 to infinity an equal to a1 plus a2 plus etc. to infinity is called an infinite series. Guys, let
Yes, ma'am.
okay,
Yes,
understand.
ma'am.
Okay, ma. Let Sn equal to a1 plus a2 plus etc. an, the whole term. Okay, if we take Sn, Sn is the sum of the first n terms of the series summation an. Okay, summation an. Okay, we know that summation a is a1 plus a2 plus etc. What is the S1 here in an? Sn is nothing but this thing. Sn equal to this. S1 first term. What is the first term in the right hand side?
A1.
A1.
A1. S1 is nothing but A1. S2?
A1 plus A2.
A1 plus A2, sum of the first two terms. Okay, not only S2 equal to A2. Okay, sum of the first two terms. S3, sum of the first three terms. Okay, A1 plus A2 plus A3. Okay. Okay, note. Summation an converges if Sn converges. Summation an is converges if Sn converges. Okay. Next, test, comparison test. Overall, I think seven tests are there. comparison test, Cauchy's root test, Leibniz test. One second. Like 7, 8, I think 7 or 8 tests are there. But all the problems are small problems only in this chapter. This is the statement, comparison test statement. Let summation un and summation vn be two series of positive terms such that limit n tends to infinity un by vn equal to L. L is a non-zero finite number. Then together summation un and summation vn both converge or diverge. Converge or diverge. That is, summation un converges if and only if summation vn converges. Summation un is diverges if and only if summation vn also diverges. Okay. This is if and only if condition. You should remember the test. This is the comparison test statement. You should remember. Let un, summation un and vn be a two series of positive terms such that limit n tends to infinity un by vn equal to L. Okay. L is a non-zero finite number. Non-zero finite number. Then summation un and summation vn both converge or diverge. That is, summation un converges if and only if summation vn converges. Summation the un diverges if and only if summation vn also diverges. This is one problem, but I have to explain on the board problems. Okay. Today. Please put it on full page. You did not see the full page? You did not see the full page, guys?
Yes, ma'am, we saw.
Ma'am, visible.
Visible only, but on student.
Yes, ma'am. It's quite short, ma'am. I'm using it on the phone, ma'am, so it's quite short for me.
Okay. I will post in the WhatsApp group. Okay, I will send.
Yes, ma'am.
Thank you, ma'am.
Okay. Okay, guys. The problems I will explain in the next class. Okay, because I have to explain on the board only.
Okay, ma'am.
Okay, ma'am.
Okay, ma'am.
You just remember that the sequence definition, series definition. What are the examples for a sequence? Monotonically increasing sequence, decreasing sequence, and then comparison test also. On second, I will explain this statement. If I explain on the board, I am very comfortable. Okay, guys.
Yes, ma'am.
Okay. Each test, if I explain one or two problems, you can easily understand. You don't worry. This is very simple chapter. Okay. Okay. 1 second. What is the time now? Yeah, 15 minutes more.
Yes, ma'am. Ma'am, we can also do tomorrow.
Afternoon time. That's why I didn't.